So in this video, we're going to look at the difference. This is a T-chart, simple T-chart, and we're going to look at the difference between pure atoms and isotope atoms. Well, what's the difference, Mr. Woods, between pure atoms and isotope atoms? Well, pure atoms, we know, are atoms that have the same number of neutrons as there are protons in a given atom. And isotopes are also atoms, but they're atoms that have a different number of neutrons than protons. So, and why is this important? Why is this particle count important? Why does it matter, Mr. Woods? Well, in understanding substances and in understanding matter, we spent quite a bit of time in class already looking at density and coming to understand that density is all about, how tightly matter is packed into a given volume of a substance. And so the atomic mass, the particle count, or the atomic mass of an atom has everything to do with the density of the substance that the atoms make up. So, if you have some substance that we would call iron, the atoms of iron have a lot of protons in them, and so they also have a lot of neutrons in them, and so those atoms have greater atomic mass than say carbon, or say oxygen, for that matter. And so when we look at the atomic mass of any given atom, we're actually looking at a measure that has everything to do with density. We came to understand in class already that density is when we compare mass to volume. And mass is on top, and then the fraction bar, and so we have mass divided by. So if we have different quantities or different quantitative measures of atomic mass, then those atoms are going to be more dense. An atom with a higher atomic mass will be more dense than an atom with less atomic mass. So that's part of what we need to come to understand about the density of substances. So let's just look at this chart really quick. And I have here, we're going to look at helium, we're going to look at a pure atom and an isotope of helium, we're going to go to a pure atom and an isotope of carbon. And I've actually named these atoms based on their particle count. So helium-4 would be an atom that has 4 particles in the nucleus. Helium-3 would be an atom that has 3 particles in the nucleus. Carbon-12 would be an atom that has 12 particles in the nucleus. Carbon-14 would be an atom that has 14 particles in the nucleus. So I want you to pause for just a minute, and let's just look at helium-4. I want you to pause the video for just a minute, and I want you to see if you can kind of sketch or draw what you think helium-4 would look like. I'd like for you to do that right now. Just pause the video and then see if you can sketch what helium-4 would look like. 4 particles. The only particles in the nucleus are protons and neutrons. See if you can sketch that. Okay, so if you've tried to sketch that and you've started the video again, so let's just take a look at what this atom would actually look like. And I think I can get it to come up here. So we see here is an atom that actually has 2 protons, those would be the particles with a positive charge, 2 neutrons, those would be the particles with a neutral charge, not negative, but a neutral charge. The electrons always have the negative charge. So if helium-4 is a pure atom and the particle count is 4, and two of those are protons and 2 are neutrons, and by the way, can I look at the periodic table and tell what the nucleus of the atom is actually going to look like? So let's look for a second. The nucleus of the atom would actually have 2 what? Do you remember what this number is? The atomic number. Atomic number tells us what? Anybody remember? You could look back at your notes. It's the number of protons. Tells us how many protons are in that in the nucleus of that atom. So if there are 2 protons, so let's get back to this. So if there are 2 protons here and 2 neutrons, and that makes up the total 4. What would this atom of helium-3 look like? Remembering that helium has how many atoms? Looking over here, it has how many protons? And then if it's got a particle count of 3, see if you can sketch this atom. Pause the video and then see if you can sketch it, and then turn it back on and see if you're right. Okay, so I think you're back now. Let's take a look at what this atom would look like. So this particular atom, there are the 2 protons. We know it's got 2 protons because it's helium. If it didn't have 2 protons, it wouldn't be helium. It'd be some other atom. So we have 2 protons and 1 neutron. There's a particle count of 3. And so I know that, number 1, this is an isotope. It's also got an atomic mass that's less than the atomic mass of helium-4, a pure atom. And so helium-3 will have 2 of those 3. Let me just get a pointer here. So 2 of those 3 atoms, 2 of those I know are going to be protons. And then the other one, so 2 plus, how many particles are in there? 3, so 2 plus 1. That one right there, I know that that's going to be a neutron, because I know that 2 of these particles have to be protons. Okay, and then the other one is going to be a neutron. All right, so let's take a look at these other 2 particles down here. So we have carbon-12. If we come over to the periodic table and we look at carbon, and here's carbon, we see that carbon is an element that has an atomic number of 6. So if that atomic number of 6 is going to tell me how many protons are going to be in carbon, then let's go back to the chart here, and what will this atom look like, carbon-12? How many will be protons? How many will be neutrons? Pause the video and see if you can sketch that, and then start it and you can take a look. Okay, so hopefully you've sketched that, tried to sketch that video, and here is the atom carbon-12, and you can count them. So carbon-12, 6 of these carbon atoms, 6 of these carbon particles, 6 of these, let me get a little pencil I can draw with. Here we go. So 6 of these are going to be protons, and the other 6 are going to be what? Neutrons. Count them. 1, 2, 3, 4, 5, 6. Total particle count, 7, 8, 9, 10, 11, and 12. It really is as simple as this. It really is as simple as counting and to know what a particular atom is going to look like given the proton count, or given the particle count. So carbon-14. So here's carbon-14. What do we think carbon... Pause the video, please, and see if you can sketch what carbon-14 is going to look like. How many protons will carbon-14 have? Well, again, let's come over here. We see that carbon has an atomic number of 6. Carbon has an atomic number of 6. And with an atomic number of 6, that tells me there are going to be 6 protons in carbon. And so if we go back over to our video here, our chart, if 6 of these, let me get my drawing pencil back, if 6 of these 14 are going to be protons, how many will be neutrons? See if you can sketch this atom. See if you can sketch this atom right now. Okay, you paused the video, but you're back. Let's take a look at what this atom looks like. And we see that this atom has 14 particles in it. We could count them. There's 6 protons with the pluses, and there are 8 neutrons. 1, 2, 3, 4, 5, 6, 7, 8. That's a particle count of 14, and I know that this is an isotope because it has a different number of protons than it does neutrons. So hopefully this little video clip will help you to understand a little better the difference between pure atoms, what I'm calling pure atoms, and isotopes, and also give you a little better insight into particle counts and how particle counts actually tell us um, about the mass of a given atom and about whether the atom is pure or whether it's an isotope. Okay, so we have one more paragraph to read in this first 6 paragraphs. We're going to read that quickly, and then we'll have some activities in class that we'll be practicing building some atoms in class. Okay, so we'll go ahead and if you haven't read the 6th paragraph, please read that before you look at the next video.